And there are some conflicts though. Conflicts on removed IDs. So let me resolve that.
Okay.
So on this branch, like merge in the main branch, and we have conflicts in the removed IDs. Old names for grammar tokens. Yeah, guess we should add these to the end. So, no luck getting reviews so far. I'm not surprised. I'm not giving any reviews either because it's feature freeze crunch time.
Oh, yeah, okay.
Anyway, for this stream, I would like to continue.
Very good.
So if we look at expressions, so what's after the generator expressions we just covered? Well, it's yield expressions. So we can either go for yield expressions and then generator iterator methods, which are somehow jammed in here in a way that I don't really like. And there's examples, and there's asynchronous generator methods. So this ideally would get moved somewhere else to some runtime section.
Oh, yeah. You mean the generator,
iterator methods, and then there's asynchronous generator iterator methods, which are somehow in the expression part of the documentation, which is like weird. Wonder if there's a good place for them. And there's examples using yield from in what's new in Python for 3.3, referenced from the documentation. Yeah, that could be shoved around as well. And well, after this section, which well, there's yield atom, yield from, yield expression, yeah, which is referenced from this yield atom. So yield atom is parenthesized yield expression. Yield from is one part of yield expression, and yield expression has a yield list, which is defined somewhere else. So one option is to dive into this and start separating the method documentation from the syntax docs. Another option is to go on to primaries and leave yield expressions for later. I think we did a bit of that with private name mangling, maybe.
Well, I guess it sounds like the yield expression. Excuse me, the methods and moving that to a different part would be like a separate PR.
Oh, definitely.
And that may not be a bad idea, because then it could. I'm thinking out loud here. It could then potentially support like subsequent improvements. It might make subsequent improvements of that part of the documentation easier.
Yeah, the trouble is it'll be a whole rabbit hole on its own.
Yeah,
I'm not really sure about the
yes,
scope.
of course. Yeah.
So
We should stay focused. Maybe we should stay with the grammar stuff and
yeah,
kind of just raise
maybe
that.
Maybe we could just improve the grammar stuff and keep the sections here.
Yeah, exactly. That's what I mean. It was
Where would
just
that go?
recognize that that's a rabbit hole and move on.
So we have a section in the library documentation on built-in types, which is
Oh, that's right.
which isn't really a good place for it. Right? You have numbers, text, lists, dicts, type annotation types, other built-in types, and there's modules, functions, methods, and so on. So this is where this stuff should be, but if you look at the documentation for types, it references function definition. Syntax docs, and it doesn't say anything about what kind of attributes you can find on a function.
Oh, that's actually, to be honest, I've often found that a little bit mysterious and confusing.
Well, because that is in a place where you wouldn't look for it, right? So the types and members of a function are documented in the inspect module of all places.
Oh my god!
Right.
Okay.
So yeah, these are the attributes you can find on a function. You can see they're all dunders. They're all namespace because you can add your own attributes. So Python doesn't.
Right.
Python 3 doesn't mess with your namespace there. But yeah, so this this is historical, I think. So the way this happened, I think, is we first had the inspect module, and then we then the inspect module looked at these like implementation details, and I think nowadays it's better to just use these dunder attributes. And of course here you have the async generator and coroutine, and the generator iterator methods like send and throw and close would fit in well here. But what I really think we should do is add a new page here. So just like we have built-in types,
yeah,
we should add a new page for
built-in attributes. For attributes,
like runtime objects or something like that.
Oh, that's
for
good.
Modules,
Yes.
classes, functions, methods, codes. Like not the types you use for data, but for types you use, the types that represent your program and its execution. right? So ellipses can stay here. Internal objects, right? Stack frame, traceback. There's standard type hierarchy. There's none not implemented. Oh, this is now the data model. Huh. So there's there's another part of the documentation where this kind of information is. So this is back to the language reference.
Yeah.
And the language reference is kind of weird. So you have an introduction, then you have lexical analysis, which is kind of syntax. Then you have the data model and the execution model.
Well, we have runtime components.
Oh dear. Right, so you have machine process, Python global runtime, Python interpreter, thread, and thread state. Which is nice. I wonder if like putting it here is the right place. So you have data model, execution model, import system, and after that it's all syntax. So expressions, simple statements, compound statements, and top level components. And this seems to me like, you know, two things jammed into one section, right? Well, one's the grammar, and one's the data model. And of course, the data model is then kind of repeated in the built-in types chapter.
Right.
And I think that should be split into like the kind of the user data model, all your strings and numbers and lists, and then your like runtime objects like methods and modules. So yeah,
maybe after
that's
maybe
that's another giant rabbit hole. As I said, this is so that's why I want to stay away from this, right?
Yeah, of course.
At least for now. The end goal for these sessions is to get the syntax documented properly, and now I know I won't have it in time for EuroPython where I'm presenting it, so I'll need to do something else for that. But yeah, I'm tempted to just leave these sections here for now.
Yeah, of course, yeah. This might be something to bring up in the agenda for the doc, the monthly meeting.
I don't think there's much use talking about it if there's no person who can put in the significant amount of time.
Right. No, I was thinking more along the lines of like, raising the visibility to figure out if somebody else might want to do it.
So the problem is you really need to understand Python at a very deep level to do this properly.
Oh,
And
okay.
I think I know all the people that could do it, and I know nobody has the kind of time to do it. So,
Right.
yeah. I can talk to PSF people. Maybe they want to hire someone.
Yeah, I
Give
was
them the
thinking
time to
exactly
do
that.
it.
It might be. Yeah, I was thinking exactly that. It might be worth like making it into, like basically hiring somebody who would focus on that, and then they could refer. They could be managed or guided by, one
Right.
of the Illuminati.
But again, there's not a lot of people who can do this
Yeah.
without significant input from the people who can do this. Yeah, so, I mean, if you ask me, you know Python well and you want to improve the dogs, what should be the next thing to look at? Well, after syntax, which is just plain wrong in places, so I started working on that. It's definitely this, like the data model and the built-in types. There's some movement towards splitting this page up, which will help a bit. But yeah, this duplication of information which really dates back to the times where you couldn't create custom classes, and you couldn't create classes that acted like lists and things like that. Yeah, this all needs moving around and merging, and that's the next big project after this one.
Okay.
So one thing we can do is look at yield expressions and leave the foreign sections here. Another thing we could do is look at primaries and come back to yield expressions later. I guess yield expressions are a reasonable next thing to tackle, so let's do that.
Okay.
So I'll create a branch for it. Create expressions yield. And I'm building on top of the list sets and dicts. So let's get that opened.
Oh, are we doing it in a new branch?
Yes, expressions yield.
Expressions, yeah. Okay.
So it's building on top of the previous pull request. So we'll probably need to rebase a bit or merge and stuff. But yeah,
Okay, yeah.
this will be a new pull request. So as is traditional, this starts with the grammar, which is not that bad. Maybe let's start by looking at the actual grammar and see. So we have no yield atom, of course. So yield atom is a kind of atom. And so we have x tuple group, list group, blah blah blah. And the group. The group can be a yield expression or name expression. So let's see. Let me rebuild the documentation. And once it's built, go. Expressions. So we have group and yield atom separately. Which I guess is fine. So the actual grammar has group, which combines yield expressions and named expressions. We have assignment expressions. That's the name for named expression here. Should really make a dictionary of these, like, old names to new names. So that's one part of the branch, and then yield expression is another part of this branch. But I think it's easier documented separately. So you have group tuple, and then yield atoms, and then generate expressions, kind of in order of simplicity. So if we go to yield atom, which would be this yield so yield expression here corresponds to this yield expression here. And that is yield from expression. So yield from expression, that's the yield from form, or yield and optional star expressions. Yield list. Huh. What's a yield list?
Oh, I never heard of that.
So yield list is an expression list, or a start expression, comma, start expression list. A start expression. Okay, let me bring this up. So yield list is an expression list, or star expression, comma, star expression list, right? An expression list is an expression, comma separated list of expressions. So start expression list is a comma separated list of start expressions. And start expression is star or expression. And what's expression list? It's a list of expressions. So what's the difference between start expression list and expression list?
The star.
Yeah, one allows stars.
I mean, I'm sure it's more sophisticated than that, but
one of them allows stars, but is expression list a subset of start expression list? Right, so expression list is expression, a comma separated list of expressions. Start expression list has exactly the same structure, but instead of expressions, it has start expressions, and start expression can be an expression.
Right. So it's basically something that it's not an assignment, not a flexible expression.
Well, what I'm trying to say is that start expression list includes every instance of expression list, right?
Oh, every.
Like if you do something, something can be either a start expression list or an expression list. Well,
I see what you're saying.
You could just say it can be a start expression list that includes all the expression lists as well. The problem here is yield list has expression list, or it has this star expression list that needs to have at least one comma. Why is that? I don't know. So
At least so far, it sounds like it might. There isn't a
can you
tuple
do
hiding in there somewhere.
yield this? No, you can't use start expression here. Can you do this? Yes. Ha. Ha. Okay. Okay, that makes sense. Okay, so if you start with a start expression, you need to follow it up with a comma. You cannot just have a start expression like that. Which is interesting. If you look at the actual grammar, there's star expressions, and the star expressions need to Oh, this is a bit complicated. Well, I guess the can't use start expression here doesn't really appear at the grammar level. Right. That comes from codegen.c. So this is can't use start expression here. Alright, so this restriction is something that appears in the code generator and not in the grammar itself, apparently.
Okay.
Which is interesting and kind of validates my approach of putting the grammar later, because I mean, so this is wrong. This is trivially wrong because you can have yield on itself like that, and that's not covered by the grammar. The yield list here needs to have an expression. There's nothing optional, and yield from, of course, needs to as well. So what this yield list? Go ahead.
Would that make it an implementation detail?
No. No, it's definitely part of Python the language. Like every other implementation of Python must include this detail. It's just a detail that's not expressed in the grammar, right? So what the parser does is it parses everything, gets the parse tree according to the grammar definition, and then it looks at the tree and says, oh, you can't do this, right?
Oh, I see. Okay.
So as far as the grammar, as far as the formal grammar is concerned, this is fine. This will parse fine. But there's an extra step that looks at this and says, nope, can't actually do that. And this fact is an implementation detail, right? You could implement Python the language where this check is part of the grammar.
I see. Okay.
Okay, so let's try the grammar snippet here. What's the syntax for this? I need a group. Okay, group Python grammar, and we need to define the yield atom, which will be defined as all this. Right, yield expression. The actual grammar calls it yield expr, which is fine. A yield expression will then be either yield from expression, and we can do it like this: yield from expression, or yield star expressions. And we need to, instead of star expressions, we need to I guess do this yield list, but really we can do a start expression list. Right, which is the same thing. Yeah, we probably want to say definition of the start expression list here. So it's start expression followed by an arbitrary number of other start expressions and a comma. I probably want to write that out here. So this yield list is a yield list used anywhere else? No, but it's referenced in the text.
I see.
Okay, let's so then yield list, let's define it here rather than elsewhere. So that will be it'll start with expression. So that's one or more comma separated expressions. We have a syntax for that, which I think goes like this. Let's look at the definition of gather. Oh, we don't have gather yet even. What? We don't have gather yet? We need to add that. S.e plus, yeah, that's gather. So one or more expressions, one or more comma separated expressions, or it can be start expression, comma, and more start expressions. And start expression list here is defined further. Yeah, so in this case, the previous grammar is actually more correct or more complete than the grammar Python uses, because that has an extra step that's not expressed in the grammar itself. So yeah, as far as grammar goes, I think we're correct here. This is really interesting. And I also need to undefine yield list from here. It's really better defined up there. So the previous definition was this expression list or star expression comma star expression list. Yes, exactly the same thing. So yeah, we basically have the same thing as before. Nice. Let's dive into the text. So the yield expression is used when defining a generator function or an asynchronous generator function, and thus can only be used in the body of a function definition. Using a yield expression in a function's body causes that function to be a generator function, and using it in an async def function's body causes that coroutine function to be an asynchronous generator function. Right. Can we shorten that? We probably can. Can only be used in the body of function definition, and then this repeats using this in a function's body, which is kind of given. Anyway, for example, def generator yields a generator function, async def generator asynchronous generator function. Due to their side effects on the containing scope, yield expressions are not permitted as part of the implicitly defined scopes used to implement comprehensions and generator expressions. I think we have better wording for that. Oh wait, no we don't. Oh, we do here. Yield and yield from expressions are prohibited in the implicitly nested scope, which is kind of the same thing. But I just noticed we have a section here we haven't covered. Generator expressions. Oh. Our previous pull request doesn't touch that. I just missed it.
Okay.
Let's get that done first.
Okay, good, fine.
So let me get back to the branch from the pull request and make a new branch. So expressions gen exp. We note this branch. Right, so generator expression. So you got here in the pull request that I've sent, and now we need to do this one. Sorry for that. Little preview of what's coming up afterwards. So generator expression is a compact generator notation in parentheses. Does that is a compact generator notation? What's generator notation?
The display?
I have no idea what the author meant by this.
Maybe they really mean display.
Kind of. So if you look at container displays, I already note that there are no tuple displays somewhere. Oh no, there are no tuple comprehensions. There it is. There are no tuple comprehensions. A similar syntax is instead used for generator expressions, from which you can construct a tuple. So if you clicked on generator expressions, you'd see a generator expression as a compact generator notation in parentheses. Yeah. Sure. What does that mean? So if we look at formal grammar, then this looks exactly the same as listcomp and setcomp. It's called generator expression. I think we have, we have that linked from Adam. So a generator expression yields a new generator object. And I wonder if this section should be after yield expression, which define how to which is how to define generator functions, which of course assumes that you already know how to define functions themselves. It's kind of circular, but that's fine. So let me read through this. A generator expression yields a new generator object. Its syntax is the same as for comprehensions, except that it includes in parentheses instead of brackets or curly braces. This is nice. I would maybe start with that even.
Yeah. And maybe start with an example. Like this. What does square generator give you? A generator object.
Nice.
And what do we have next? Variables used in the generator expression are evaluated lazily when the next method is called. Whoa, what's the next method? generator next. So this this actually references generator iterator methods. So what's a generator
this is what we're
iterator?
trying to avoid.
Maybe we want to use the same trick as for the generators themselves, as for the comprehensions, right? We can say this is roughly equivalent.
I like that
To
because it shows a
defining
certain
and calling
kind
the
of,
following function, and here you do define square generator of iterable, and then you we even don't need to assign it to a variable. Make generator of squares, and you make the generator of squares. Let's make the example the same. So instead of creating a list and returning it, you yield. And assuming you know what yield does, generator expressions are now very simple, right? So yeah, we need to put generate expressions after yield expressions, because once you know what yield does, this is this is extremely simple. This just does whatever comprehensions do, but yield stuff. Let's read through this to see. If we can cover all of that. So values used in the generator expressions are evaluated lazily when the next method is called on the generator object in the same fashion as all the generators. However, the iterable expression is immediately evaluated, as in that example, and the iterator is immediately called for that iterable, so that an error produced while creating the iterator will be emitted at the point where the generator expression is defined. Right. So this call is basically part of what happens, right? So if something is wrong with this, if I make a typo here, like x range, I get an error immediately. So yeah. Subsequent for clauses and any filter condition in the leftmost for clause cannot be evaluated in the enclosing scope, as they may depend on the values obtained from the leftmost iterable. Huh? I can do this. Can I not? Yeah, that's fine. The parentheses can be omitted on calls with only one argument. I think that's for calls. Yeah. But this is... yeah, this is important. For example, if I turn this into a tuple right away, I can do that. But if you look at the syntax closely, this comprehension needs parentheses around it, and the call syntax, of course, needs parentheses around it. So if there was no exception, I would need double parentheses here, but I don't, because there's an extra affordance in the grammar that says you can omit these parentheses. If you only have,
it's only got one argument.
If you only have one argument. If you have two, then that's a syntax error, and you need to put parentheses around the generator expression. Now, of course, tuple doesn't take another argument, but that's even a comma. Like if you put a comma after the generator expression, can't do that. Next up, to avoid interfering with the expected operation of the generator expression itself, yield and yield from expressions are prohibited in the implicitly defined generator, and this is exactly what comprehensions do already. From expressions are prohibited in the implicitly nested scope. So here they are prohibited everywhere. Can I do this? No, I can't. Can I do this? Yes, I can. Okay. So yeah, even here I can use yield expressions. Anywhere else I cannot. If I put more for loops in there, it can't go here. But that is exactly the same thing as for comprehensions. A bit tricky, but we already covered that trickiness. So if a generator expression contains either async for clauses or await expressions, it is called an asynchronous generator expression, and an asynchronous generator expression returns a new asynchronous generator object, which is an asynchronous iterator. That probably needs an example. What should we... an example with async for. No, I don't think we really have a good object for async for. So no example there, we'll just leave it. Okay, so what do we do here? We probably want to do this after the yield. So yield first, then this. And sorry, I need to go away for about 2 minutes. I'll be right back.
No problem. No problem, yeah.
So I will shove this branch.
Okay.
And I will go back to the one created earlier. Skip the generator stuff for now and go on to yield expressions where we prepared this better grammar snippet. And how far did we get? Yield expressions are not permitted as part of the implicitly defined scopes used to implement comprehensions and generator expressions. So this is repeated up here. To ensure the comprehension always results in a container of the appropriate type, yield and yield from expressions are prohibited in the implicitly nested scope. Which is like one of the last things we say about comprehensions, which means it's one of the innermost details. Right? It's the thing you need to learn almost last about comprehensions. So maybe we want to push this sentence a bit further away. And yeah, this change in version 3.8, I wonder if we have that. Yes, we have that up here as well. I don't know if we want to keep this. Anyway, generative functions are described below. Well, asynchronous generative functions are described separately in section asynchronous generative functions. Hello.
Oh, asynchronous generators. I love asynchronous generators.
Doesn't everyone? Do you love explaining asynchronous generators?
Oh, this is fun area because coroutines are generators and asynchronous generators are like a double fold thing. Yeah, it blows my mind. But I helped with PEP 828 bringing async yield from 828.
828.
Yes.
Yeah, that's nice, Pep.
Yeah, we're kind of cleaning up things because I added the test suite, which is I just copied it over from yield from tests, and then I just use regex to replace defs with async defs, and that's mostly what was done. And some were passing, some still aren't, and we had gotta fix it. So yeah, fun stuff. By the way, I have some PRs. If you will have some time left, then.
Are they feature PRs that need to go in before beta?
Good question.
If not, I'm not reviewing them this week or the next. Like this and next week's 2 hours are the only time I'm spending on documentation.
All right. Yeah. So I think I have only one feature. It's something that you actually suggested. So, but I also asked Kirill to take a look today in the evening. Let me send this in the chat.
Okay, send it to me and I'll take a look at it. If it's not documentation, then it's not on topic here. So
oh yeah,
I'll look at it tomorrow.
So I have something documentation related though, but
right. So I guess this now goes on to explain what happens at runtime. So at runtime, when a generator function is called, it returns an iterator known as a generator. That generator then controls the execution of the generator function. The execution starts when one of the generator's methods is called. At that time, the execution proceeds to the first yield expression where it is suspended again. Returning the value of yield list to the generator's caller, or none of yield list is omitted. By suspended, we mean that all local state is retained, including the current bindings and local variables, the instruction blah blah blah. When the execution is resumed by calling one of the generator's methods, the function can proceed exactly as if the yield expression were just another external call. Okay. The value of the yield expression after resuming depends on the method which resumed the execution. If next is used, typically via either for or the next built-in, then the result is none. Otherwise, if send is used, then the result will be the value passed to that method. Okay. Yeah, that's all runtime behavior though. All of this makes generator functions quite similar to coroutines. Well,
Yeah.
they yield multiple times, they have more than one entry point, and their execution can be suspended. The only difference is that a generator function cannot control where the execution should continue after it yields, which isn't really true for coroutines either. The control is always transferred to the generator's caller. And I think this use of the word coroutine predates Python coroutines. Is that correct?
Oh, predates the implementation of coroutine. I mean, the enhanced. It was coroutines via enhanced generators. I think what that was. That's 352. 352. No, I was missed that one. 342. Yes, 342.
Yeah. So this text was written in 2007.
Wow.
Right.
Yeah, but we already had coroutines in 2005. No, I don't know. But the PEP to add coroutines was in 2005, before I was born. Shortly before I was born. It's different. It's PEP 342 actually. 342. Yeah.
Coroutines were via enhanced generator 2005.
But we don't know when it was implemented, in fact, right? Because this is what the PEP created, and but we have Python version, so Python version 2.5 was released 2006.
So what does this do? New syntax. Yield allowed inside tree. Try finally. New generator method throw. Generator exit exception. Close. And delete. Extended continue statement. Ooh.
Reading this is so fascinating, like imagining those times. Actually, I can pull up a Docker image probably, like 2.5.
Basically what this does, it adds send and throw. That's the meat of the syntax mix, meaning that the yield expression, yield is an expression now which has a value, and you can set that value via send, or you can throw in an exception that's raised inside inside the generator, but it still doesn't give the generator function control over where the execution should continue, right? So this is a different meaning of the word coroutine, and I think we should just get rid of this.
Right, because generator functions are kind of bare bones coroutines.
Yeah, so this is the general concept of coroutines from other languages like Lisp, which work a bit differently. So yeah, now that we have now that we have coroutines that don't do this, we should remove this one. Anyway, next up, yield expressions are allowed anywhere inside a try construct if the generator is not resumed before it's finalized. The generator that is closed method will be called, allowing any pending finally clauses to execute. But doesn't this always happen? Hello? Yeah, this is a bit weird. Anyway, when yield from expr is used, the spliced expression must be an iterable. The values produced by iterating the iterable are passed directly to the caller of the current generator's methods. Any values passed with send and any exceptions passed to a throw are passed to the underlying iterator if it has the appropriate methods. If this is not the case, then send will raise attribute error or type error, while throw will just raise the passed and exception immediately. Nice. That was like the PEP has the implementation for this, and it's really really giant. It's really good that you can say this in 5 lines. Those are packed with information.
Would be useful to have a link to glossary about iterables.
Oh yeah.
Iterable is tricky. Even typing didn't get it right.
Well.
Yeah, we were talking about that earlier.
Yeah, typing iterable or collections ABC iterable is not the actual iterable.
Oh, it's not?
It's not. It's not because it doesn't catch the ancient protocol with like where you can have a class that implements get item and raises index error.
Oh.
Yeah, so it doesn't catch that one. You don't need a dunder iter to have a type that is iterable. You may also have a sequence protocol. Well, yeah. So, but this is an edge case.
That's an edge case that you can't really express in typing.
Exactly. Unless we had.
Well, so for as far as typing is concerned, if you want something to be iterable, you better define under iter.
Yeah, exactly. I mean, if we had intersection and negation types, then maybe, maybe, in a way, it would have to be a union, though. I don't know. I don't know.
No, you can do that with union, but you need to check that iter can take integers.
Oh, true.
And those integers are indices, right?
Yeah.
And we don't have a separate type for indices versus general integers. Anyway, let's go on. When the underlying iterator is complete, The value attribute of the array stop iteration instance becomes the value of the yield expression. Oh, this continues the yield from. That should probably be its own section. Yeah. Can be either set explicitly when raising stop iteration or automatically when the sub iterator is a generator by iterator. Now I'm lost.
Wouldn't it be helpful if there were examples everywhere?
Well,
I know this wouldn't be like.
That's what I'm doing, right?
Oh, really? Oh, okay.
Yes, that's the purpose. Add examples to this dense text. I didn't really do a good job with asynchronous comprehensions, to be honest.
Do you know how to write the shortest asynchronous comprehension in Python? Because this is actually a fun puzzle. How to write the shortest one, like the shortest empty. That will like.
Oh, let's do it.
Yeah, it's funny.
So
please. Yeah.
How to write the shortest, like how to write the smallest asynchronous generator. Yeah, that was not
so it needs to be an async def function, right?
It wouldn't be a function even. I mean, it would be. Yeah, I'll write it in the chat. But it would be.
Well, then it's not much of a puzzle.
No, actually it is because. No, I don't remember. Oh yeah, it was using that. Oh wait, yeah, it is a puzzle.
Anyway, so this is yield from. The parentheses may be omitted when the yield expression is the sole expression on the right hand side of an assignment statement. So we also had this for oh, and not for functions? Wait. Not for calls? Oh, so this isn't for calls, this is for assignment. Okay, so we need to rewrite this. And probably add a new section for yield from. Then there's generator and iterator methods, which we want to move outside, so I'll skip it for now. Here's an example of the behavior, so that's also runtime behavior.
I pasted in the chat the thing I meant with async generators. You can put in a weight in the comprehension, and this will make it an async generator. And like some type checkers even don't know that this is possible. It's actually incredible.
That's evil.
Tricky stuff, yeah. I think that's from 3.7. Oh, this doesn't need to be parenthesized, by the way. Value, yield value.
What?
The example. Value equals yield value doesn't have to be parenthesized.
Right, yeah, but it's a bit clearer this way.
Ah, true.
So I'd like to move these out, and then we go to asynchronous generator function. So the presence of a yield expression and function method defined using async def defines the function as an asynchronous generator function. Right?
Presence of a yield expression. What if it is what if it is present in an enclosed function, in a nested function? Playing a lawyer now.
Yeah, we're not really. The expression yield from express is syntax error when used in asynchronous generator function. Well, there's a pip for that, right?
Which one? Oh yeah. There's a pip for that.
Then we have asynchronous generator iterator method. So anyway, this basically describes the runtime semantics of asynchronous generator functions and asynchronous generator iterator methods, asynchronous generator iterators. Okay, so basically this is all we should cover in terms of syntax, as I see it. So let's do it.
One caveat with yield expressions is that you cannot print them without parenthesizing them. So for instance, you can assign to a yield expression, but if you do print and do, I don't know, yield like this would be a syntax error because yield has to be parenthesized.
Yeah.
Oh yeah, that's exactly what we were showing. Yeah, of course. Yeah, this is a funny caveat. Yeah.
Well, it always has to be parenthesized. So the
Yeah.
yield expression.
That's probably because of commas. It wouldn't be clear if it's if you're like, because you can yield an expression that contains a comma and is not parenthesized.
Well, not just commas. You do like 1 plus 2. What's the operator precedence? Does yield take the 1 or does it take the 1 plus 2?
Yeah.
So, I mean, you can define it either way as the language designer, but it's better to be explicit.
Yeah, good point. Yeah. Interesting.
So yeah, the yield atom is always parenthesized, and there's a special exception. The parentheses may be omitted if it's the sole expression on the right hand side of an assignment statement. I think that's the only exception. Is it? So we can't do return yield? No. So how do we start here? The yield expression is used to define a generator function or an asynchronous generator function. Or maybe we start with the yield expression can only be used in the body of a function definition. Using a yield expression in a function's body causes that function to be a generator expression, to generate function.
Directly, provided that it is direct, not in a nested function. I don't know how to write this, and if it's even a constant.
It can only be used in the body of a function definition. Well, directly. I mean, what does directly mean, right?
Directly means that it's not in a nested in a function. So like you cannot have def, and inside that nested def there's a yield, because then that nested thing. So like the closest, I don't know. It's tricky. I don't know.
Now there are two things that matter here. There are function definitions and class definitions, right? So the scope is important. So the two things that create scopes in Python, class definitions and functions definitions, are also the two things that enclose like the effect of the yield, right?
Correct. Yeah.
So
I'm only the second. I'm only thinking about the second, like to kind of include that, like tiny, but it's probably not that important. I don't know.
So using yield expression in a function's body is redundant because it can only be used in the body. Causes the enclosing function to be a generator function. For functions using defined def, and we can put on a keyword.
But you can use lambda yield. I mean, you can use yield in lambda, right?
Right, yes.
Yeah.
Do we have async lambda already?
Why I lambda yield. That's the best thing ever.
I think there is an async lambda, is there?
No, there is no need for an async lambda because you can just call the coroutine itself in a way. In most cases.
Right. Yeah. We have maybe 10 more minutes, or can we run over?
We cannot. Let's do it like this. First do the simple case and then expand. And I don't... Maybe I want to take this sentence and put it like somewhere deep down below.
Function.
Yeah, thanks.
Cool, yeah. Broaden the scope and then refine. Classic.
Maybe I want to spend some words on this enclosing thing. And maybe tie it together with scope somehow.
Closest containing function, no.
So let me look at how we document scope.
Good idea.
So that's an execution model. Resolution of names. The scope defines the visibility of a name within a block. If a local variable is defined in the block, its scope includes that block. What's a block?
I think block is just expression. No, statement list. I think that was.
A block is a piece of Python program text that is executed as a module. The following are blocks: a module, a function body, and a class definition. Ta-da!
The list of statements.
Each command typed interactively is a block. A script file is a code block. A script command is a code block.
Yeah, it's a list of statements at the same level of indentation.
No.
No? I
No.
mean, not really. Because they can, if it's continuous, then it's a block.
No.
Continuous list of
The following are blocks: a module, a function body, and a class definition. That's it. Well, okay, then a script file and a script command and
modules.
interactive command, right? The important thing here is that for loops and if and with are not blocks.
True.
Right? Yeah. And this is exactly what we want to use for the effect of yield. Right?
Yeah.
So
Yes.
the yield expression can only be used directly in a function definition block. So this would be the correct way of saying it, except this requires you to know what a block is.
Directly is maybe a little, I don't know.
So we probably need to explain a bit more, but yeah, this maybe a note. What does this say? must be a better way to explain this.
You want to say something like can only be used directly in a function definition block, specifically bodies and class definitions? Or do you want to maybe have a reference to the section on the execution model that we were just looking at?
Yeah, that's this reference, the proc structure.
Oh, yeah. Sorry, I didn't see it. Okay. Definition? Oh, I see. So not as part of like the init, but rather.
Now what I'm trying to say is, if I'm defining a class, then I can't use a yield here. Oh, it would be.
Oh, right. Okay, got it. That's nice. Yeah. That's very clear. At least that's clear to me.
But if I have a class here, then again, right?
Oh, I see.
And if
so
I
it can be
have-
included in the function block, but not the class definition block. Okay.
If I have a nested function, I can have a yield here again.
Tricky. I mean, tricky to explain, not tricky in practice. Although this is technically incorrect syntax, because if you just put a comment there, it would expect something. Let's make it a docstring, yes.
Yeah, well, I like to.
Oh, pass, yeah.
I like to
Pass.
put a docstring there in my own code, but it's probably better to do that here.
Double nested. Yeah. Underscore missing. Yield 1, pass. Oh, and you can put a yield in a method, of course. And you can make a lambda in a nested class with a yield.
Wow, this is fascinating.
Yeah.
I have a very silent like no, I have a very small gut inside me to double check that this doesn't crash, but I wouldn't believe that this would crash. This is like impossible.
Well, I hope it doesn't crash, but of course I will check that.
Like, who knows? You know, recently I've seen
Yeah, it's fine.
Yeah, it's fine. I recently seen like a bug with like some.
This is a
if you have
generator.
a garbage of a generator in some special place, then a coroutine would think that it was awaited twice. So and since then, I have an OCD. like this is so many things.
Anyway, we are out of time, so we'll continue later. And what I want to do is probably say here that this directly is kind of load bearing and will be explained later, and then put this complexity in a separate section.
Yeah.
Just to make it simple first. Okay, so that's all for today, and same time next week. Yep, same time next week.
Yeah. Did we do a commute?
No, sorry. I will not be here same time next week.
Oh.
Yeah, there's an event and the little one's kindergarten I cannot miss. And the week after that will be the beta release week. So if Python 3.15 beta 1 comes out as planned, we'll see each other in 2 weeks. And if not, I will be probably firefighting, and I'll see if I have time. So maybe 2 weeks, maybe 3 weeks.
Okay.
But thanks for your attention today, and see you in the